Alright guys, so in this video, we're going to introduce congruence and what it means to be congruent. Alright, so introduction to congruence. So this is going to be a new standard, alright, 1.2. So let's start off with the definition. Okay, so the definition we're going to use for congruence is a two-dimensional figure is congruent, okay, and this is the symbol for congruence, to another two-dimensional figure if the second figure can be obtained from the first by a sequence of rigid transformations. All right, and recall the rigid transformations are rotations, reflections, and translations. So what we're saying here is we're saying a two-dimensional figure is congruent to another one if we can take the original one and rotate it, translate it, or reflect it in any way we want, and then we end up with the first one to be on top of the second one, pretty much. Okay, we'll look at examples and then it'll make sense. All right. Real quick, this is the symbol for congruence. Okay, it's like an equal sign, and this little the squiggle up here is actually called a tilde. Okay, that's tilda, tilde. Okay, so it's an equal sign with a tilde on top. That's for congruence. All right, and what we mean by congruent, okay, is so for example from algebra we saw that the equal sign meant that the numbers or the values are equal to each other. Okay, that's what we're talking about. Numbers more in algebra. Now in geometry we use congruence because the shapes or the figures are congruent. All right, and that's pretty much it. Okay, so let's look real quick. Let's see. Are these rectangles A and A prime congruent? Okay, well, is there some sort of rigid transformation we can do where we end up with A that right on top of A prime? Okay, so in other words, can we translate, rotate, or reflect A so that we get A prime? Okay, well, as you can see here, yeah, it's actually very simple to see that we can do that in this case because all we have to do is translate it down. And notice that you get A prime when you do that. Okay, so when you just translate it down, you see that A falls right on top. Okay, the angles fall right on top of each other too. Okay, when that happens, we're good. We just say we're congruent. Okay, so same thing, you could even move this here. Is there something you could do to get A on top of A prime and all the angles, and the angles be the same? And yeah, there is. All you could do is translate right, translate down. There you go. Since everything's on top of since we got A prime from translating, okay, notice we're translating, okay, which is one of the rigid transformations. Since we translated A right on top of A prime, yeah, we can. Okay, so we can see that A and A prime are congruent because we translated. All right, maybe it looks like this. Okay, so now is there something we can do to get rectangle A prime from rectangle A? Well, yeah, what could we do real quick? Well, we could rotate, right? Rotate 90 degrees, and then we could translate it down, and there we go. We're congruent again because everything lines up, okay? Because we got A prime from performing rigid transformations, right? We rotated real quick. That's one of the rigid transformations. And then we translated down. That's one of the rigid transformations. And we ended up with A right on top of A prime, so we get congruence. Okay, and you could do other stuff too. Okay, so let's see if we could. Let's look at this. Let's look at these. So maybe we could do the. Let's look at the diamonds. Okay, so these diamonds. Is there something we could do where we could get A prime? Maybe we'll start off with this one real quick. This is the simple case, okay? Is there something we could do to A so that we get A prime? Yeah, all we would have to do here is rotate it 90 degrees to the right, and we're good. Okay, we just rotate it 90 degrees to the right, and we get it. How about if I moved A prime down here? Is there something we could do to A so that we could get it to fall right on top of A prime? Okay, well, yes, we could rotate to the right 90 degrees, and then rotate another 90 degrees, And look at there. All right, so we're A is right on top of A prime, so we say they're congruent. Okay, and that's so it's very straightforward. All right, so you could even do this, right? So let's say we started here. Is there something we could do to A so that we got A prime? Yeah, all we'd have to do is rotate it 90 degrees counterclockwise, right? That'd be counterclockwise, okay? Rotate it 90 degrees counterclockwise and look, okay? So it falls right on top of each other, all right? And because we rotated, which is a rigid transformation, we're good, okay? So that's pretty straightforward. How about these trapezoids, okay? So let's look at this trapezoid real quick. And let's see if we can get this trapezoid, maybe we'll call it T for trapezoid, okay? Is there any way we could get this trapezoid maybe to look like, I don't know, maybe this T prime? We'll call that T prime. Is there something we could do, okay? Now notice these angles, we want these angles to fall on top of each other too, all right? So let's see, is there something we could do to T so that we get T prime? Well, let's see real quick. I think what I want to do is I want to reflect T over the y-axis. So when I do that, I get this. Okay. Now make sure you're following. Okay. So follow the 4 and follow the 3. Look where the 4 and the 3 are ending up. Okay. The 4 and the 3 they're gonna stay in their spots. See them? They're right here still. Okay. Same thing with the 1 and the 2. Okay. So now we can say this one is T. Okay. It's still T. All right, we just reflected it. Okay, we reflected over the y-axis. So we reflected, now we're here. Well, what else could we do now? Well, maybe we could do a little rotation to get into quadrant 4. So a rotation by 90 degrees, look like that maybe. Okay, clockwise, right? So we're like this, and this is a rotation clockwise. And then 90 degree rotation clockwise. And then what can we do real quick here? Well, we can already see. All we would have to do now is translate to the left, and there we are. Okay, so we get the 4 falls right on top of the 4, 3 is on the 3, 2 is on the 2, 1's on the 1, and the entire shape is on T prime. Okay, the entire T is on T prime, and we say they're congruent. Okay, so congruent just means, is there a way you could adjust the shapes using the rigid transformations, rotations, reflections, and translations, so that you get the original figure, okay? Normally, this is called the pre-image. And the one that we're trying to get to, or we're trying to see if we can get to, is called the image. All right, and so yeah, as you guys can see, it's pretty straightforward. All you have to do is see if you can rotate, reflect, or translate to get there. All right, and obviously, maybe we'll look at these line segments. Maybe we'll talk about these line segments real quick. Maybe we'll look at something that's not congruent. Is there a way to turn this 50 units into this 200 units? No, because no matter what we do, remember from the introduction to rigid transformations, you can't change the length, okay? So no matter what you do to rotate, translate, okay, you could try to reflect it, okay? You could try to reflect it like that. You're still not gonna get the 200 units, okay? So we can't change the size, okay? We're not changing the size for congruent. Congruent has to mean we're not gonna change the size, but we can still get the same shape, okay? So which is like what we did here. We rotated, we reflected, right? And then we rotated, and then it fell right on top, okay? So that's pretty much all it means. It's a very straightforward concept. We probably won't spend too much time on congruency. Just know it just means that when two shapes pretty much fall right into each other, okay? That's gonna be it for this video. Thanks for watching. Oh, actually, guys, I actually wanted to introduce something really quickly, okay? And I just wanted to talk about what a rotation by 90 degree is, okay? So let's try to pretend maybe this thing's like a little skateboard or something, all right? So when you do, let's say you did like a 90 degree turn on this thing, okay? So I think it'll be easier to see here. A 90 degrees clockwise looks just like this, okay? Another 90 degrees clockwise looks just like this, okay? But now look here. Look how we started off. We started off with T. So we did two 90 degrees clockwise. Well, two 90 degrees clockwise is the same thing as one. So here was the two 90 degrees. 1, 2. Okay? That's the same thing as just doing a 180 degree clockwise, right? And then of course, if we're starting like this, so maybe this is the original, maybe we do a 360. Okay, so what happens when you do a 360? You fall right back where you are. Okay, so let's see. 360, so here's 180. Okay, so here's 90. Okay, here's another 90. So far we're at 180. Here's another 90. So now we're at 270. And here's another 90. Now we're at 360, back to where we are. All right, and same thing, you could rotate. You could do a 90 degree rotation counterclockwise, right? So here's counterclockwise, 90 degrees. Here's counterclockwise, 180 degrees. Here's counterclockwise, 270, right? So we started like this. So 270 would look like this: 90 plus another 90 plus another 90. That's 270 degrees counterclockwise. And of course, one more 90 gives us a 360. Okay, so hopefully that makes a little bit more sense with the 90 degree rotations. Okay, so real quick, so if this is the 90 degree rotation, maybe this, if we go, so this is a 90 degree, right? So we're rotating 90 degrees clockwise. Maybe we'll go halfway, 45 degree rotation. Okay, maybe we'll go a little bit less than halfway. So maybe if this is 90 and this is a 45, I don't know, maybe we say that's like a 30 or something. Okay, so you can mess around with the degrees and how much you rotate. So maybe this is 90 degrees. Maybe this, since this is 180 degrees, maybe that's 90, that's 180. So maybe that's somewhere in between, like 120 degree clockwise. Okay, so that's pretty much how the degree stuff works. All right, thanks for watching, guys. See you in the next video.